Number 1, consider the circle with center at 3, -1 and a radius of 4. Give the equation for this circle in standard form. Okay, I'm just going to begin with the standard form equation with some blanks in it for us to fill in. So the h goes here, the k goes here, including that sign, and the radius goes here. And then let's go ahead and clean this up. X minus 3 squared. Change this one to y plus 1 squared equals 16. Expand your equation to obtain a quadratic equation in 2 variables. Okay, so we're taking x minus 3 and foiling it. X squared minus 6x plus 9 plus, same thing with the y plus 1. So that is a quadratic equation in 2 variables. I mean, it's fine as it is. If you want, you can get one side equal to 0, so it kind of looks like the one that we did in class. X squared minus 6x, let's see, plus 9 plus 1 is 10. Move the 16 over to the other side, and we get minus 6 at the end. If you really feel like scrambling it up, you can group the x squared, well, put the x squared and y squared terms first. Let's see, write a parameterization of this circle. Okay, so we'll begin with x equals and y equals. I'm going to put sine on the first one and cosine on the second one. That's an arbitrary choice. We know that we discovered in class that the radius goes in front, so 4 in the front of each of these, and then the center gets added or subtracted at the end. Plus 3 for the x coordinate of the center, minus 1 for the y coordinate of the center. So these questions are really easy, really short if you know the formulas. Consider the circle defined by the parametric equations that. What are the center and radius of the circle? Okay, so same idea, but now working other directions. So the center must be at -5, -2. Just copy those numbers as they are. Don't change their signs. And then the radius of the circle must be the number that's in front of the sine and cosine, which is 3. Notice that it had to be the same number in the front of sine and cosine. If the numbers are different, we'll talk about one of those at the end of this activity, and then we'll get into those more next class. Give the equation for this circle in standard form. Okay, standard form again. I'll start with my shell. Okay, so we just wrote down the center up above. We might as well use that. -5 here, -2 here. Minus signs in the formula are going to change those numbers. And then 3 squared over here. And then we'll just clean that up. X plus 5 squared plus y plus 2 squared equals 9. See, compare this circle to the one parameterized by that stuff. Okay, let's see. We decided that the center was -5, -2. What's the center of this one? -5, -2. Okay, same center. We decided that the radius was 3. What's the radius down here? Well, also 3. Okay, so then we can say definitively, same center and radius. So then it's going to be the same circle if you're just looking at it after it's been drawn. But if you watch it being drawn, then you might see some differences. For example, they might have different starting points, the 2 circles, and they might have different orientations. One could go clockwise and the other counterclockwise. So the best way to figure out what these things are doing is we're going to plug in t equals 0 and also t equals pi over 2. Okay, so I'm going to do this quick, so feel free to pause the video if you need a little more time. So plugging in t equals 0 here, sine of 0 is 0, this part is all 0, -5 is the x coordinate. Plugging in t equals 0 here, cosine of 0 is 1, 3 times 1 is 3, -2 plus 3 is 1. So this guy starts at the point -5, 1. And let's see whether it's going clockwise or counterclockwise by plugging in pi over 2. Sine of pi over 2 is 1, 3 times 1 is 3, -5 plus 3 is -2. Plug in pi over 2 here, cosine of pi over 2 is 0, 3 times 0 is 0, so the whole thing is just -2. Okay, and so then a real quickie sketch will give us a sense here. So -5, 1 is out here, negative 2, 2 is, sorry, negative 2 is down here. And we said that the center of the circle was negative 5, negative 2, which is there. So this circle is getting traced out clockwise. So this one starts at negative 5, 1, and goes clockwise. You have to play the same game for the other circle. So I'll put it up here, plugging in t equals 0 and t equals pi over 2. Now into these equations here. Okay, so let's give it a shot. Plugging 0 in. Cosine of 0 is 1. 3 times 1 is 3. Minus 5 plus 3 is negative 2. Comma. Sine of 0 is 0. That whole thing is 0, so the whole thing is negative 2. So this one starts at negative 2, negative 2. That's the difference. And let's plug in the other point to find the orientation in which it's drawn. Cosine of pi over 2 is 0. 3 times 0 is 0. That whole thing is negative 5. Comma. What are we plugging in? Pi over 2 right here. Sine of pi over 2 is 1. 3 times 1 is 3. Minus 2 plus 3 is positive 1. Okay, so then this circle starts at negative 2, negative 2. It's exactly the same dot, but I'll put it a little bit next to, and ends at the point negative 5, 1, which is that dot. But I guess that means it's going the other way. So then the other circle starts at negative 2, negative 2. That's what we got when we plugged in t equals 0. And it goes counterclockwise. 3. Consider the circle defined by the implicit equation x squared plus y squared plus 6x minus 10y plus 24 equals 0. Rewrite the equation in standard form. Hint, don't those squares seem incomplete? That's exactly what I was thinking. So we're going to first group the x terms in the front, leave some space. We'll put the y terms next. And then I'm going to shove that negative 24 over to the right-hand side. It's harmless. I'm going to add the magic number, b over 2. 6 over 2 is 3. Square it, you get 9. Right away, subtract 9. Or if you're really efficient, just add 9 to both sides. b over 2 for this next one, negative 10 over 2 is negative 5. Square that is 25. And then right away, subtract 25. Notice you're always adding something, because when you square, it always becomes positive. So you always add, and then right away subtract. Okay, these terms right here, if you factor, you get x plus 3 squared. These terms here, if you factor, you get y minus 5 squared equals, and now we're going to be clever and move everybody to the right-hand side. So we're going to add 9 and add 25, which will take care of this minus 25 and minus 9. Add it to both sides so they move over to the right. So if I'm doing this right, we get 10. So that's our equation in standard form, from which we can easily do part B, center and radius. Center, here we do have to change the signs. X plus 3 gives you a minus 3 for the x coordinate in the center. Y minus 5 gives you a positive 5 for the y coordinate. And then the radius, okay, this one's not a perfect square, but I can tell you a number that when I square it gives me 10, and that's the square root of 10. C says write a parameterization of the circle. Well, this is really easy now that we've got the previous answer in front of us. So the radius goes in front of the sine and cosine in either order. And then the center gets stuck on at the end. Don't change the signs when you do the center here. So that's it. Consider the implicit equation x squared plus a quarter y squared plus 4x minus y plus 4 equals 0. Explain how you know this equation doesn't define a circle. All right, this is that typo that I fixed. we need to look at the coefficient of x squared and y squared. And if they're the same, it's going to be a circle. If not, who knows? So the coefficient here is 1, coefficient there is a quarter, not the same. Coefficients for x squared and y squared are not the same. B, what do you get if you complete the square for both x and y? Okay, well, we can complete the square even if it's not a circle. So let's try this. It'll be a little tricky because of that quarter. But in the beginning, it's the same process. Move the x squared terms to the side, or the x terms to the side. Move the y terms, group them together. And I will move that 4 over to the other side by subtracting 4. Okay, the first part, the x part is easier. In fact, I'm just going to copy it because we've got to do another step for the y part. The y part is trickier because of that 1/4. So remember the step you have to do if a is not 1, and that step is to factor out that a term from both the first two terms, the y terms. So factoring out the 1/4 from the y squared gives me just y squared. But this is trickier because there's no 1/4 to factor out. There's nothing in there to factor out. So what do you get when you factor out a quarter from this number, which is at the moment a 1? Well, hoping that you guys can come to the answer of a 4. If you need a little bit of help on that one, I'm going to write that as a 1 and say whenever you factor, you're taking whatever you have and dividing it by what you're factoring out. So you're taking the 1 that's currently there, dividing it by a quarter. We know we need to flip that thing over, and that gives me a 4. If you're still not convinced, distribute this 1/4 back through and confirm that you get exactly what we started with. Okay, so now it's time to add the magic b over 2 squared. So for this first one, b is 4. b over 2 is therefore 4 over 2 or 2. Square that and we get 4. Right away subtract 4. Next thing is to look in here. This is the new b, even though b is technically -1. We got to look at the changed b that's in the parentheses. So we take -4, b divided by 2. Divide that by 2 to get -2. Square it to get +4. And then right away subtract 4. Except this was the funny business because that +4 in the parentheses isn't really a 4. It's some other number in disguise because that 1/4 is going to come out and multiply by the 4. So if we do down here, the 1/4 times the 4, we get a +1. We really added 1 to the left-hand side. So then right away, we need to subtract 1. Very tricky. Okay, the rest of this is going to be pretty straightforward. I'll use a little bit of the space for c. Factor this thing, x plus 2 squared, plus 1/4. Factor this thing, y minus 2 squared, equals, all right, there's a -4, and then we have to move the other terms over to the other side. So that subtract 4 and that subtract 1 need to both get added to both sides. So that's our equation. C, try to graph this equation by either parameterizing it or writing it as 2 explicit equations and describe your graph. Okay, so let's do that here in part C. So in order to graph on our calculator, we need to solve for y. So unfortunately, that's a bunch of work, but let's do it. So I'm gonna put a little line through here to ignore that. So here's our equation. It's all that stuff with x and y equal to 1. Don't FOIL, but rather just focus on solving for y. We need to get y equal so we can type it into our calculator. So let's subtract x plus 2 from both sides, or x plus 2 squared. So that moves over to join the purple 1. And then we can multiply both sides by 4 to get rid of this, the 1/4 in the front. And then we can take the square root of both sides. And we're going to not forget to do the thing that's so easy to forget, and that's to put in the plus or minus when you take a square root, and then finally add 2 to both sides. Okay, there's our 2 explicit equations. I say 2 because of the plus or minus. And finally, we can graph this on our calculator. So let's give it a shot. So very carefully typing that whole thing in. So we go 2 plus the square root of 4, and then new parentheses, 1 minus, and then more new parentheses, x plus 2 close parentheses squared. You don't actually need to put any more parentheses at the end, but you can if you want to. And then the same thing here, but with a minus sign. Okay, so if I've typed that correctly, then we should see the curve that is this thing, which isn't a circle, but it's not really clear what it is. So let's take a look, maybe zoom 6. Kind of looks like a circle. Let's do zoom square, number 5, which will maybe pull this one apart a little bit better. Okay, so if it isn't a circle, I mean, it kind of looks curvy. I don't know what's going on in the space in between. This is a weakness of the calculator. These 2 curves should be connected to each other. I'm going to try changing the window one last time before I bail on this and just say, you know, there's better technology than what we're trying to do this on. So what if we go from like -3 to 0 and then zoom square? Okay, that didn't change anything. Let's try it again. -3 to 0. Graph. Okay, so at least it's not disconnected anymore, at least not too badly. So it, I mean, it stretched out because I messed with the axes, but if it's not a perfect circle, then it sure feels like it's just an oval. The math word for that is an ellipse. I think if I do zoom square, no, it just goes back. Okay, so it's an ellipse, and the graphing calculator that we're using has some very apparent weaknesses when it's trying to graph the ellipse. So one thing you can do is go to Geogebra, which is a free download. And the nice thing is you don't have to go through any of this algebra where you solve for y. We're just going to go back up to the equation that we had from before with the x's and y's all mixed up. Okay, so I'm just going to carefully type in this equation right here. X plus 2 squared plus all that stuff equals 1. Okay, so I think I've typed that correctly. I'll hit enter, and there it is. No fuss, no muss, definitely an ellipse. Axes here are scaled the same, so we don't have to think that it's been stretched artificially, right? Because we could stretch this thing and make it look like it's an ellipse going the other way, or we can make it look like a circle. So it just depends on how it's stretched, but oops. But that's what it really looks like with the axes scaled the same. We didn't have to go through this artificial business of solving for y. Geogebra is kind of nice in that way. And in fact, it looks like they've done some funny stuff up here too. X squared plus 0.25 y squared plus 4x minus y. Did we ever have that? No, I think we did actually. That was this equation. So they automatically FOILed it all out and combined like terms and got that thing that was in blue.